So here's kind of the background on it. What it means, why it is what it is. So in a circle, if you drew a circle and you drew it so that you have an angle coming out from the center, so it's called a central angle, when the radius is the same length as the arc length, we call arc length, that's S. So if the distance from the center to the edge of the circle is the same as the distance from around the arc, that's what is called 1 radian. So when your radius is equal to your arc length, your angle is equal to 1 radian. Okay, so that's kind of how it's determined, what a radian means. If we want to find the radian measure, then all we have to do is arc length divided by radius, S divided by R. Radians do not have a unit. Arc length is a distance around the outside of the circle, radius is a distance. So those would have the same units. It would be like 6 inches divided by 2 inches. Well, what happens if you do inches divided by inches? Those cancel. So from now on, anytime I see a number without a label, I'm going to assume you are talking about radians. So if you aren't, you better have a label on it. Okay? Anything?
So it's not 3 inches?
No, it would just be 3. You could write the word radians if you wanted, but it's not necessary. So anything without a degree symbol is automatically assumed to be radians. So now we are to the point. If you don't have a degree symbol, it's wrong. You're done. I've been warning you for 2 months. It's time to get with the program. Okay, so let's look at this example. If you have I guess I just kind of did this one out loud, didn't I? A central angle in a circle of radius 3 centimeters cuts off an arc length of 6 centimeters. What is the radian measure? So your angle is 2 radians, or you could just say 2. The word radian is not required.
Can I draw a picture of the R is the line, the S.
S is the distance on the outside.
So S would be here.
Inside right.
I just have 3 S's and S every time I look at this picture.
All right. So if we're going to have 2 different forms of measuring, we really need to have a way to go back and forth between the 2. Okay. If we have inches and feet, but we can go back and forth between the 2. So let's figure out how to relate them. In a circle. Okay. Arc length is distance on the outside of the circle, right? So if you travel all the way around the circle, the arc length is the entire distance around the outside of the circle. What's the word for that? Well, what's the distance around the outside of the circle? Circumference. So if you go all the way around, that is equal to the circumference. Okay? So if we go all the way around, we know our angle in radians is S divided by R. S would be the circumference, which is 2 pi R divided by R. So a full rotation in degrees is 360 degrees. In radians is 2 pi. Or if you want to reduce, you could divide by 2. So 180 degrees is equal to pi. If you want to put radians, you can. So to go back and forth, 180 degrees is equal to pi radians. All the way around the circle is 2 pi.
was pi radian?
Mm-hmm.
I'm guessing you're just gonna have us put pi instead of doing the,
Yes, we will use the pi symbol, not 3.14.
I'm already drawing my pi symbol over here, so I don't know. It's like a slanted, I don't know.
any pi symbol drawing tips?
Apparently. About line, line, line.
I did like my left line, like all.
That looks like a.
Looks like a.
Yeah, I usually make
It's
it.
like a Japanese.
It's like a. I do a J,
Yeah.
long line.
I'm doing like a line and then like
Oh,
a
I'm really
J.
going to have to analyze all of your pies.
Like this.
on the
This is
next
my
one.
pi symbol. Is this not correct?
It just looks a little.
180,
It's having a fun one.
Okay,
360.
so if I asked you to convert these things into radians. All right, we've done conversions before, right? When we had the rotations and we want to know how much it spun in 2 seconds or something. If we want to convert degrees into radians, we need to get rid of our degrees, right? So we just said 180 degrees is equal to pi radians. If I want my degrees to cancel, it has to go on the bottom. So if we have degrees and we need to convert it into radians, we'll take it times pi over 180, because then our degrees will cancel. We typically try to keep these as nice as we can, so don't put the pi in your calculator, because it will plug in the decimal and we don't want that. But you could do, what's 45 over 180 reduced to in fraction form? 1/4.
Yeah.
So we will call that pi over 4. So 45 degrees is equal to pi over 4 radians. And the radian is not required to write.
What about rads?
You can if you really want to. So if I want to change 450 degrees into radians, what do we multiply by?
Pi over 180.
Or could we do 2 pi 360?
You can. It'll give you the same thing. So 450 over 180 in lowest terms is,
5 halves.
so we'll say 5 pi over 2. All right, negative 78.4 degrees. Okay, the negative will just stay. So if we put that in, the negative is no big deal, so 70.4 over 180. And it gives us a pretty ugly, so negative 98 pi over
How did that number get bigger?
225, because you had to get rid of the decimal.
Oh yeah.
If it's something that really won't turn out nicely, which is possible, you might go to put it in your calculator and it won't give you a fraction. If you're going to keep a decimal, you might as well multiply out the pi. So don't tell me 0.33333 pi. Go ahead and just do the times pi in your calculator and give me the final decimal.
Do you get the fraction on the calculator?
Math number 1.
Just math enter.
Oh, and then do you put your answer in?
Well,
No,
it should, yeah.
if you do your
just
answer
let it
first
pull up
and
right
then you math enter.
Yes. Okay.
Alright, you're welcome. So now, let's go the other way.
This orange is huge.
So, if I, if I told you to change pi over 6 radians into degrees, one thing I want to stress, it's not the pi that makes that radians. Okay, it doesn't have to have a pi to be in radians. A lot of times it will, but it's not required. It's the fact that there is no degree symbol. That's how I know this is radians. So if I want to cancel my radians, what would I multiply by?
180.
Over
5.
pi. So we are doing pi over 6 times 180.
Degrees.
So my pi's cancel. 180 divided by 6
30.
is 30. But if you put that, I am counting it wrong.
Degrees.
Degrees.
Close.
All right, 4 pi over 3. So we multiply by
180
over
pi
pi.
over pi.
pi's cancel, and we get
720 divided by 3. Whatever that is.
It'd be 240.
240
degrees. Negative 4.5. If I want to change that into degrees. Okay, so a couple different ways you could write this. The pi doesn't cancel out this time. So you could do negative 4.5 times 180. So you could write it as like negative 810 over pi degrees. Or if you went ahead and divided it, use the pi button on the calculator. Don't try to plug in 3.14.
So we do negative 810 over pi.
Mm-hmm. And it gives you negative 257.831 degrees. So a couple different ways you could write that.
But you would accept the first one?
Yep. And from now on, anytime I give you something without a degree symbol, it's radians. Okay. Let's see. I don't know if I'm going to be able to get through this whole thing, but we're going to. We are going to start our unit circles today. And I do have a circle. Okay. We are going to start with degrees today. Okay. So what are the common degrees on our hand?
0, 30, 45, 60, and 90.
Okay. We also know this line would represent what? And this one?
270.
What's another?
360.
Yeah, you could also call, instead of 0 degrees, you could call that 360. They are the same because they are, what's that word?
Complementary. No,
Quad-
co-groups.
Co.
Oh, co-functions.
Co-functions.
So,
Co-
dang it, no! They are coterminal. They end at the same spot. Okay.
What did Grant? Your pride?
Yes, I'm proud of Grant today. The rest of you are failures.
Whoa, whoa, whoa. Let's not be hasty.
Okay. So, if this is 180 degrees, okay, think about our reference angles that we did. If I wanted to get this one right here,
Wouldn't it be 150?
yes, how'd you get it?
I subtracted 30. I didn't.
Yeah, 180 minus 30 is 150. How would I get this one?
Subtract 45.
180 minus 45.
135.
135.
Okay, this one we would do 180 minus 60.
120.
That is 120.
Okay, how do we get them in the third?
You add.
Add 180 plus 30,
210.
180 plus 45,
225.
180 plus 60,
240.
Oh.
That Carson's trying.
Okay. Then at the end, what would we do?
Subtract.
Subtract from.
360.
360.
Okay, so 360 minus 30.
330. I accidentally put that in the right.
360 minus 45.
315.
And 360 minus 60.
300.
300.
I did that. Yeah, I added to the 270.
So remember, reference angles are distance from the x-axis, so
Yeah.
that's what we have to use those. Do a quick check around the circle. Notice your angles are increasing. If you accidentally flip something, you should catch it by doing that because they should go in order. So you can't go from 240 down to 225. It should be getting bigger as we go around the circle. All right, are we okay with that? So now, let's get our radian measures. So, 0 degrees. We know if you have a degree and you want radians, you take your degree times pi over 180, right?
Yep.
So what is 0 times pi over 180? 0. 360 times pi over 180 is
Just 2 pi.
2 pi. So 0 and 2 pi, they are the same place on the circle because they are coterminal. They mean 0 is you haven't started 2 pi, you've traveled all the way around. All right,
Seems suspicious.
30 degrees. So if I take 30 times pi over 180,
Pi over 6.
okay, 45 degrees. So if I do 45 times pi over 180,
Pi over 4.
if I do 60 times pi over 180,
Pi over 3.
does everyone know where we're getting these?
60 divided by 180.
Mm-hmm.
Okay.
All the numbers divided
And then
by
I slap that pi on there.
90 times pi over 180.
Pi over 2.
What happened to my denominators as I went up?
They're going down.
Slowly are decreasing.
Okay. What is, let's jump down to 180.
Pi over one, it would be just pi, right?
Pi.
That's just pi.
Okay, so we have a lot of ways to get the rest of these. I could do it the same way. I could do 150 times pi over 180.
Wouldn't it just be go back down?
We could also think of it like we did with our degrees. We did 180 minus 30, right? So I could do pi minus pi over 6. Pi is like 6 pi over 6 minus 1 pi over 6.
Pi over pi.
Do 150 over 180. Does that give you 5 over 6? Probably, I hope so. Otherwise, I've been lying to everyone for years.
They just never check.
What a great
Yeah.
Wait,
teacher.
what am I doing? 60.
So 6 over 6 minus 1 over 6.
Mm-hmm.
So 5 over, is that equal 5 over
Mhm.
6?
Can I have the other way you just said?
I said you could also do 150 times pi over 180.
Times. I keep wanting to divide by 1.
Well, you do because the 180 is on the bottom.
Then you get
And then
math.
number
Oh,
one.
then you math it.
Whoops, not a second. Yes. So 135, this would be like pi minus pi over 4. So 4 pi over 4 minus 1 pi over 4 is 3 pi over 4. The next one would be, how did you get those so fast? Yes. So you saw a pattern though.
No, you flip them from the other way, right?
Okay, look at my denominators. These are both 6, 4, 3.
Oh,
And the top was 1 less because we were subtracting from pi.
How does it go
Wait
from 5
a
to
second.
3?
From 5 to 3. Well, I'm looking at my denominators. And you're doing.
See that now.
Okay.
But how does the top work?
Okay, so think
Can
about.
you write this
We did.
subtraction out for me?
Mhm. So it's like doing pi minus pi over 4. Okay, common denominator. This is like 4 pi over 4 minus 1 pi over 4.
And you get 3.
3
Got it.
pi
Oh,
over
you
4.
selected.
Alright.
Okay. Let's talk about the third quadrant. If we're doing reference angles, what do?
And.
We add. We did 180 plus 30. So if I do pi plus pi over 6.
Is it
7 pi over 6.
7 pi?
2.
Yeah.
Wait.
7 pi over 6.
Is it? Did I
Because
do
this
yes?
is our reference angle of 30 right now. Okay,
So then you're
the
just
next one.
adding 9 pi over 6.
Well, this would be pi
I mean, over
Pi
4.
plus pi over 4.
5 pi.
Oh, I thought I figured it out.
What? It decreases? Oh, over 4. Never mind.
Okay, the next one is when we were dealing with a 60. So it would be like
Okay,
pi plus pi over 3.
3
So it would
pi
be
over 2. No.
The pi would be
4
over, it'd be
pi
over
over
3.
4 pi over 3. It's close.
okay, 270. Maybe we don't know that one. Let's try the other way. If I did 270 times pi over 180.
That would be 3 pi over 2.
Just showing you, there's a lot of ways to get these. Okay. Let's talk about this last quadrant. Everybody make sure you have this filled out because this will be something that we are going to reference daily.
Reference angle this daily?
Yes, we will reference our reference angles daily. Okay, so how did I get 330?
You subtracted 30 from 360.
I did 360 minus 30. So if I'm dealing with radians, it would be 2 pi minus pi over 6, right? This is like 2 pi over 1. So if you got a common denominator,
So it'd be 11 pi over 6.
Oh, why?
Interesting.
Okay, if you do 2 pi minus pi over 4,
Is it 9?
be 8 pi over 4 minus 1 pi over 4, 7 pi over 4.
That's not the same pattern as before. I don't like that.
How much you wanna bet the next one is over 3?
Ooh. So 300. So if I did 2 pi minus pi over 3. Yeah, it's like 6 pi over 3 minus 1 pi over 3. So 5 pi over 3.
So
I'm really
it's
struggling with these
like
conversions to start with.
3 times 2, and then that's 6
Why not
minus
remove
1
it
is
like
5.
Mm-hmm.
4 times 2 equals 8, minus 1 equals 7.
Mhm.
6 times 2 is 12 minus 1.
Yeah.
No.
Okay.
Triangle.
So
Circles.
we are supposed to get dismissed in like 90 seconds. So I'm going to stop here for today.